All right, hey guys, I don't know if anybody's watching this, but I thought I would go over some calculator reminders for those that are interested. The problems that I picked are only multiple choice because I'm trying to focus not necessarily on concepts, but on using your calculator for the concepts hopefully you guys have all been studying and have been perfecting over the last couple months. So I picked multiple choice questions that are really easy if you use your calculator right. Again, so not like super tricky ones that just should be straight calculator stuff. So first thing, like always, is to make sure you're in radian mode. So, okay, here we go, radian mode there, all right. Now, let's take a look at 78. All the questions I'm going to do in this video are from the 2012 calculator multiple choice. That's the test I gave you over spring break to work on. And if you don't have it anymore, like the paper version, I've got more here at school, and I also have it on Canvas in the tab that says spring break work, okay? So number 78, the graph of y equals e to the tan x minus 2 crosses the x-axis at one point on the interval from 0 to 1. What is the slope of the graph at this point, okay? So this is definitely one that you should use your calculator. So the first thing I need to do is I need to find where this graph crosses the x-axis between 0 and 1. So I'm going to come over here to my calculator, and I'm going to type in that equation. So e tan x minus 2. Okay, so just type it in. That graph should be fine. So it says where it crosses the x-axis in the interval from 0 to 1. Okay, so that would be the point right here. So I'm going to go and I'm going to find the 0. I want to make sure I'm left of that. And right. Okay, so that would be the point. Now, that's not the answer. That's just the x-coordinate of the point where the graph crosses the x-axis there. So then what I'm going to do is if I want to find the slope there, that means I want to find the derivative at that number, okay? So if I go into my calculator menu, remember that if I have my variable button, that's automatically saved as whatever the most recent x value I solved for is. So then I can take that and I can store it in for a letter. Okay. Now I can go math, go down to number 8, and derive. I'm doing it in terms of x. Now, I already took the time to type in that equation that was in my y equals 1, the one that's right here. So in this screen, I absolutely could type it in again if I wanted to, like this, and then I could put the point I solved for there, okay? The other thing you can do is go to vars, yvars, function, y1. So that's taking the equation I already have typed into y1. And then I should get the same thing. So then if I come back over here, I know that the answer should be D on 78. Okay. So again, just trying to remind you of some calculator things, okay? Next one I want to go over is number 81. Okay. It says water is pumped into the tank at that rate, okay? where T is the number of minutes since the pump was turned on. If the tank contains 800 gallons of water when the pump was turned on, how much water to the nearest gallon is in the tank after 20 minutes? Okay, is in the tank after 20 minutes, that wants to know how much is actually there. You got to be careful because sometimes what they ask is how much water moved into the tank over the 20-minute period of time. That's asking for something different called the displacement. This one wants to know the ending amount, okay? So to figure out the ending amount, we're going to use the first fundamental theorem of calculus. Where this is my end amount, this is my initial amount, okay? So for this question specifically, this is the rate equation, so that's my derivative that goes in here. Equals my f of 20, which is what I'm looking for, minus my f of 0, which they told me was 800. Okay? So basically, you don't even have to really write that on there once you get the hang of this, but I'm going to use my calculator to do that whole thing. So I'm going to go math, go down to math 9, and I'll go 0 to 20. Type in the equation just as it looks. And I'm going to do it in terms of x. And then add my initial condition to that. And it says to the nearest gallon, so that's 1,220. So that answer should also be D. Okay. So another one made much easier when you've got your calculator. When you've got your calculator in front of you, you should really not be doing any integrating or deriving by hand. Let the calculator do that work for you, for sure. Okay. All right, next one on this test I want to do is number 82. Okay, 82. It says if f prime of x equals that, then f has a local maximum at x equals. Now, you guys really did a good job on these when I gave you the sign analysis chart. On this one, we're going to use the calculator to help us really easily make a sign analysis chart. So that, first I double check, and the equation they gave me is already a derivative, so I don't need to derive it again, because for maximums, I look at the first derivative. Okay, and I'm going to come over here to my graph mode, and I'm just going to type that equation in. So that's the square root x to the 4th plus 1 plus x cubed minus 3x, okay? So I just typed in the equation from number 82 there. I'm gonna make my window a little bit bigger just to make sure that I see all of the maxes and mins. I mean, sorry, not all the maxes and mins, all the zeros, okay? So if I'm looking here, I can see there's 3 zeros, okay? In my head, I'm going to call that one A, that one B, and that one C, okay? So this screen right here, what that tells me, if this is an f prime of x sign analysis chart, that I have A, again, that's the first one, and see, I'm not even finding these, B, and then C. Now, all these values before A, those are negative because they're below the x-axis. Then between A and B, they're above the x-axis, so now they're positive. Between B and C, negative, and then after C, positive. So there's my sign analysis chart. Now I'm looking for a maximum, and I know that my maximums go from a positive to a negative on the derivative, so that the original is increasing to decreasing. So this one's going to be a possible minimum, not maximum. So it's got to be that middle one, B. Okay? Now, once I realize that B is the one that goes from the positive to the negative, again, I'm going to let my calculator do all of that work. I'm going to find that 0. And it's 0.350, which is C for that question. Okay. And I knew I needed to find the middle one because that is the only one where the derivative goes from a positive to a negative. So I know my original went from an increasing to a decreasing, creating a maximum. Okay. Next one on this test I'm going to do is number 84. All right. It says for negative 1.5 to 1.5, okay, so that's what I know I'll make my domain. Okay, let function f have a first derivative of this. Which of the following are all intervals on which the graph of f is concave down? Okay, so when I'm looking for concave down, I'm looking for the second derivative. Now, I don't even actually have to find the second derivative, however, because instead of looking where the second derivative is positive and negative, I can look where my first derivative, the one that's given, is increasing versus decreasing. And that'll tell me where my original is concave up or concave down. So right now what I'm going to do is I'm just going to type in the equation from number 84 is the one that we're on. Okay. And it just says to do between 1.5 and 1.5. Okay, now this is the first derivative. So without having to take the derivative of this to get a second derivative and find where it's positive and negative, instead I can just look here and determine where this graph is increasing or decreasing. Now it says concave down in the question, right there. And so I know that I want where this graph is decreasing. So I know it's from there to there and there to there, okay? So already I know it can't be A because there's two possible intervals. It can't be B and it can't be E. I know it's either C or D. Now, it's probably D because I changed my window to be negative 1.5 on the X, okay? So just to make sure, let's just double check those numbers. So I start decreasing when X is negative 1.5 and I go until X is negative 1. Okay, so far that checks out. Wait for it. Okay. Remember that e to the negative 6, that's just a really small decimal, meaning 0. So far, so good. And I don't know if you needed to even check it to this point. I just am being extra careful. Checks out. Answer is D. Okay. All right. Two more on this one. Okay. Number 89. Again, I chose ones that I felt were not super tough in terms of the content and made much simpler with a calculator. Okay. So this one says a particle moves along a line so that its acceleration is given by that. If the particle's velocity at t equals 0 is 5, what is the velocity of the particle at time 3? This is super similar to, I think it was 81 that we did, because we're trying to integrate from acceleration to velocity, and it's not looking for how much the velocity's changed over a period of time. It wants to know that ending velocity. So what we're going to do is we're going to integrate from 0, because that's the initial condition value that they gave me, to 3, because that's the one that they are asking about, of that acceleration equation right there. It's t plus 3 over the square root of t cubed plus 1. Hopefully you've got the test in front of you. And dx. So that's the displacement. That's how much it changed over the interval. So if I want to know where it ended at 3, I need to add to that the initial condition that it gave me, which is 5. And I get 11.710, and that looks like the answer on that one would be E. Last one that I want to do on this test is number 92. Okay, let R be the region in the first quadrant bounded by the graph of that and above the graph of the other one, okay? So it's bounded below by that. So that is telling you that that's my bottom one, and above by that. So that's telling you that that's my top one, okay? So I know that I'm going to integrate from, it's a volume one. So R is the base of a solid whose cross section is perpendicular to the x-axis. So that tells me I'm going to do dx, r squares. Okay, so the area of a square is base times height, but the base and the height are the same thing. So the area of a square we'll say is base times base, or base squared. Okay, so I'm going to go dx. I have got my base squared right here, and my shaded region area is what we plug in as the base here, and they gave me that it's bounded below by this, so this is the bottom equation, and bounded above by the square root of x, so that's my top equation. Okay, now I can solve algebraically to get these values, but if your brain has melted and or you have your calculator in front of you, you can do that here as well. I'm going to get just a slightly better window here. Okay. So they intersect at 1, and the other one's 0. Okay. If this one was a non-calculator, just to remind you, I'd just set them equal to each other to find where they intersect. I'd want to get rid of that probably first, would be the easiest way. So square both sides. And move everything to one side. And then factor it. And the 0 of that is 0, and the 0 of that is 1. So that's the other way to do it by hand, okay? And then from there, it's just a matter of typing it in. You should be doing no integrating on your calculator portion by hand, okay? So then I have, what was it? Square root x minus x squared dx 0.333, which, what did I do? Oh, I forgot to square the whole thing. Okay, let's try that again. Now, one thing I just did there, when I realized my answer wasn't even a thing, so I knew, oh, actually it was a thing. Good thing I noticed I didn't square it. But if you don't want to have to retype everything you just typed in again because you notice a mistake, you can press second, and then you can press entry, and it will like go back through the things that you have recently typed so that you can go back in and edit them. So I'm just going to come here and I'm going to insert a parenthesis and insert a parenthesis and a squared, and then there we go, 0.129. And then that answer is A. Okay. All right. Thank you. I think I'm going to post another one with a few questions from one of those optional tests I just put up. Just again, focusing on easier questions, just so that we can review how to use your calculators. Good luck. You're doing great. Thanks.